Hello, Geometry Honors. This is lesson 1.3 or section 1.3. And today we're going to use midpoint and distance formulas. And you'll kind of see where they come from as well. So first things first, we want to look at the definition of a midpoint. And a midpoint of a segment is the point that divides the segment into two congruent sides or segments. And another way to think of it is the midpoint bisects the segment. So to draw a picture of that, they want a picture of a segment AB. So we'll go ahead and knock that out, AB. And it's got a midpoint M. So I'm just going to do the best I can to put it in the middle. But then I don't want to just make it, look like it's pretty close to the middle. I want to be deliberate about it and say, hey, this midpoint bisects this whole segment, so this is the same as that. Well, how have we learned to mark that? Yeah, that's right. Tick marks. So we've got, this right here says that M is the midpoint of AB because the segments are equal. All right, now associated with midpoint is a segment bisector. And here's the funny thing, segment bisectors contain the midpoint, okay? So anyway, a segment bisector is a point. It could be the point, or it could be a ray, a line segment, a plane that intersects the segment at its midpoint, okay? So again, the segment bisector bisects the segment. So it's similar. It says draw a picture below of line L. So let's go line L. And then line L is going to be bisecting line segment HG at its midpoint P. So what I'm going to do is draw HG, and I'm going to try to kind of balance it out to be about the same on both sides. So HG. And then its midpoint, they say they want it to be called P, so we'll put P in there. And then we want to show that P is the midpoint of HG, so again, we'll do tick marks. And this time I'll do two, just because I can. So line L is a segment bisector. But also notice line L contains the midpoint, doesn't it? All right, let's look at an example. The figure below shows a gate with diagonal braces. It says that MO, by the way, that should be segment MO. Whoops. Segment MO bisects segment NP at point Q. So if segment MO bisects NP at Q, then I know that PQ and QN are the same, are congruent. So it says if PQ is 22.6 inches, find PN. Well, if that's 22.6 inches, so is that. So PN is going to be 22.6 times 2, which, so 45.2, and with geometry, the units are important, so inches is our answer. We're just talking about a length, not an area or anything like that. Okay, let's move on to example 2. Example 2 tells us that point S is the midpoint of segment RT. Well, if it's the midpoint, we know that it bisects it into two congruent parts. So we've got like so, and it asks us to find the measure of ST. Find the measure of ST. Well, to find the measure of ST, I think I'm first going to have to find out what X is. I'm not sure about that. And so what relationship can I set up? Well, because they're equal, we can do 5x minus 2 is equal to 3x plus 8. And then let's solve this thing. Let's get the x's together. Let's move the numbers to the other side. And we're looking at an x value of 5. But that's not what they're asking us for. They're asking us to find the value of, or the measure of ST. So we'll substitute 5 into that expression, simplify it, and we'll have a value for ST. Let's double check. Do we have any units given to us? No, we don't. So we just leave it like that. Okay, example 3. The endpoints of GH are G and at 7, -2, and H at -5, -6. And it's going to ask us to find the coordinates of the midpoint P. Well, this is asking us something different than what we were talking about. It does mention the midpoint, but it's asking us for coordinates. And we don't have experience with that. So that leads us to a new relationship here. So before we tackle example 3, let's move on over here and talk about the midpoint formula. And the midpoint formula, it says in the coordinate plane, the coordinates of the midpoint of a segment are the averages of the x coordinates and of the y coordinates of the endpoints. It's the averages of them. So to generate a formula for this, here's what I want you to do. I want you to label A as some generic X and Y. But I'm also going to want you to do the same thing for B, just some generic X and Y. But these are obviously different points. So I'm going to label this one X1, Y1, and X2, Y sub 2. So this is what makes it a formula, is we don't know what XY is, but we know that they're going to be different XY values. And so it tells us that to get the midpoint, so we'll go ahead and put M as the midpoint here, and then that we know if it's the midpoint, that those are the same. It says to find the midpoint, you're going to take the average of the X's and the average of the Y's. So I don't know if you remember this from pre-algebra and such, but the average is where you add them up and divide by 2. Add the Y's up and divide by 2. Right there is our midpoint formula. And notice it's got the parentheses because it's a point, it's a coordinate. So now let's revisit example 3. Example 3 says the endpoints are 7, -2, and -5, 6. Find the coordinates of the midpoint, P. So that is tailor-made for the midpoint formula. And you can memorize the midpoint formula, that's fine. But I'd almost rather you just remember that it's the average. It's the average of the X values. So we're going to do 7 plus a -5 divided by 2. It's the average of the Y values. So we're going to do -2 plus -6 divided by 2. And then really there's no equal sign there. I should get rid of that. But point P is going to be it'll be 2 divided by 2. So it'll be at 1, -8 divided by 2, -4. That's the coordinates of midpoint P. Example 4 comes at this a little bit differently. a little bit differently. And if you want, you can draw a picture just to kind of help you out. It says, well, first read through it, the midpoint of AB. So they're starting out by giving us the midpoint. And it says one of the endpoints is at 2, -3. Well, they're wanting us to find the coordinates of the other endpoint B. And it says using algebra, not graphing. You could graph this and tinker with it and figure it out. But I'd like for you to do it quickly with just algebra. And that's a pretty big hint, some algebra. So algebra is where you've got variables, right? Here's how I want you to think of it. Whoops, let's draw a segment. You've got an A that's at 2, -3. You've got a B, which is unknown. So what I want you to do is just put, I don't know. So you put X, Y, some variables in there. And then we've got our midpoint at 5, 8. So we're going to use the midpoint formula to help us solve for x, y. So the midpoint formula tells us to take an average of the x values of the endpoints. So an average would be, I add them up, divide by 2. But what should I get when I add them up and divide by 2? I should get the midpoint coordinate. I should get 5. Alternatively, if I add them up, add the y values, divide by 2, what should I get? I should get 8, the value of the midpoint, the midpoint y value. So now what this does is this allows us to solve for endpoint x, y. I would suggest timesing by 2 to undo the division. Subtracting 2, I get an x value of 8 times by 2. Add the 3 over y value of 19. And because it wants us to find the coordinates of the other endpoint B, we want to write it as such. We have B, and its coordinates are 8, 19. So we used variables of x and y to allow us to solve for an endpoint. Pretty cool. All right, if you don't mind, let's flip it over. And on the back side here, we're going to talk about the distance formula. Now, it says in the coordinate plane, if A is at x1, y1, B is at x2, y2. So we've done that setup before. There are points in a coordinate plane, or they are points in a coordinate plane. Then the distance between A and B is. So these notes are set up to kind of give you the formula right off the bat. So I guess I'll go ahead and do that real quick. So the formula, the distance formula is big square root x2 minus x1 squared plus y2 minus y1 squared. Now that's a pretty big and intimidating formula, but I want to let you in on a secret. This formula is derived directly from the Pythagorean theorem that you've known for a few years now. Now, if you recall, the Pythagorean theorem is a squared plus b squared equals c squared. And of course, you can flip that around if you'd like, if that's the way you learned it. But do you recall what kind of shape the Pythagorean theorem was used for? Well, ideally, you'll remember that it was used to figure out sides on a right triangle. Well, I want to show you that when we've got a segment graphed in a coordinate plane, we can think of it as being the hypotenuse of a right triangle. And if we call B the second point and A the first point, we can create a formula by thinking about what the coordinate of this point, we'll call it C. We're gonna get the coordinates of what that would be to see if we can actually use the Pythagorean theorem. So I want you to notice that C is going to have the same x value as B. I want you to notice that C is up the same amount as A. Oh, and I made a mistake. Sorry about that. This is our first point, x1, y1. And now what I want you to do is to do essentially the ruler postulate. The distance from B to C is going to be the difference between these y's. The x's are the same. It's the difference between the y's. You're just going up. So you're going to do y2 minus y1. Now, in reality, you would also do the absolute value, but it turns out you don't need that, and I'll show you why here in a second. And then to find this length, this side length, you're going to do the x values. So you'll go, you can do it either way. You can do x2 minus x1 or x1 minus x2. It doesn't matter. But now that you've got this bit of information, you can set up the Pythagorean theorem. So if you're trying to find this distance here, that's the hypotenuse. This is the measure of one side. This is the measure of the other side. So the Pythagorean theorem says that the legs, in this case, y2 minus y1 squared, the leg squared, plus the other leg measure squared is going to be equal to the hypotenuse squared. Pythagorean theorem. And we're trying to find D. So how do we undo the squaring of D? You got it. We can square root the entire side. Now here's the thing. The reason we didn't need the absolute value for our ruler postulate idea here is because when you square a negative, it becomes positive. So it's going to be all right. If it's positive or negative, we square it, it's going to be positive. So you don't have to worry about it. Another thing that you might notice is normally when you undo squaring by square rooting, you have to say plus or minus. You have to include the positive or the negative. But this is a distance, and distances only should be positive. So I'll go ahead and write this in the order that we had it up above, where we've got x2 minus x1 squared plus y2 minus y1 squared. But that's where the formula comes from, is from the Pythagorean theorem. Again, you just got to know the formula, but I think it's kind of helpful to have an idea of where it comes from. And then that way it's not just a jumbled mess that you have to memorize. It makes sense. You're using the length of one side, the length of the other side, and using the Pythagorean theorem. Okay, let's try this out. Example 5 says, what is the distance of line segment PQ if it has endpoints at P 25 and Q negative 4, 8. And the instructions say round to the nearest tenth and use the distance formula to find the answer. All right, so the distance formula is big square root. And then we want to subtract the x's. It doesn't matter which order you do it. I just kind of like to be consistent because sometimes in math it does matter. So I'm going to go 2 minus a negative 4 squared plus 5 minus 8 squared. That's the setup for the distance formula. And then just take your time with it. This will be 2 plus 4, which is 6. 6 squared is 36. This will be -3, but when you square it, you'll get 9. And what you'll get is the square root of 45. Later on, you're going to learn how to simplify that. You might have learned this. I think we just started getting to this when COVID hit last year. But anyway, you can simplify this down to 3 square root 5. But the instruction said round to the nearest tenth. So you're going to grab a calculator, punch that in, square root 45, and you're going to get a decimal answer. And rounding to the nearest tenth, you should get 6.71, if I'm not mistaken. I don't have a calculator handy. I'm cheating a little bit. And there you go. You use the distance formula, and no units were given, so we are good. All right. Next up on our last example here, it says find the length of the segment graph below. Well, to find that length, you honestly could very easily, not easily necessarily, but you very quickly could do the Pythagorean theorem. Can you see that right triangle right there? You could totally do that. Or you can use the coordinates and use the distance formula. So I'm going to write that this is point A, and it's at 1, up 1, 2, 3, 4, 5, 6. This is point B, we'll say, and it is at 8, 2. And now armed with that, I can find the length of the segment by doing the distance formula. And the distance formula, big square root again. Subtract the x's. I'll do 1 minus 8 squared plus subtract the y's, 6 minus 2 squared. Clean it up a little bit. This would be -7, but you square it, it would be 49. This would be 4, square it, you get 16. So you get distance is equal to square root 65. Turns out 65 does not simplify, so the exact answer is square root 65, just like the exact answer over here is actually, well, it'd be 3 square root 5. But anyway, the exact answer to this is square root 65, but they want, actually it doesn't say to find the length to the nearest tenth, but that's what we're going to focus on for right now. So put that in your calculator, and I believe you'll get 8.06 when it's rounded to the nearest tenth. So something I do want to emphasize, exact answer, rounded answer. Oftentimes the rounded answer is more useful in the, quote, real world. Well, hey, thank you so much for watching this, and I'm actually not sure right off what the assignment's going to be. So what I'll do is I'll put that assignment in Canvas under the assignments, all right? Thanks so much for watching. I appreciate you.